Welcome back, and this is part two of our conversation talking about Swift. So let's pick up where we left off. So again, Swift is this international network. It's also an international society and a business cooperative that operates a physical network for secure delivery of messages, and they also publish standards. So how does it work? So basically, the Swift network will route messages. So assume a customer of Bank of America branch in New York wants to send money, let's just say, to a friend who's at Unicredit Bank in Venice, Italy. The New Yorker can walk into his Bank of America branch and with his friend's account number and the Unicredit Banca unique Swift code for its Venice branch, the Bank of America can generate a payment instruction to transfer money using a Swift message over the Swift network, and that message will be delivered to Unicredit Banca at the branch in Venice, Italy, using the secure Swift network. Once Unicredit Banca in Italy receives the Swift message about the incoming payment, it will clear and credit the money to the Italian friend's account. So basically, it's a secure way, and that was a very simple example of doing a transaction. Now, both banks are on the Swift network. So Bank of America is on the Swift network, and Unicredit Banca is on the Swift network. And since the message was built in the Swift format for this type of transaction, so there's a type of transaction to do a wire, a payment. So using that message built in that standard, one participant in the network can send that message to the Swift network. It'll get routed to the other participant, and that transaction will go through, and the money will be available. And once the message has been received and acknowledged and processed correctly, that money is instantaneously available. Right. So routing of messages, every participant of the network, for everybody who's on the network, all these people on the network, bankers, banks, custodians, brokerage houses, everybody who participates in the network has an address. And that address is what we call a BIC, a bank identification code. So everybody who connects to this network will have an address on the network. So when you want to send a message from one participant to another, you use that BIC code that's used to route that message to that participant. That's what the BIC code is. So Swifts assign each financial organization a unique code that is 8 characters. The code is called interchangeably. They're called BIC codes. They're called bank identifier codes. They're called bank identification codes. They're called Swift codes. They're called Swift IDs. They're called ISO 9362 codes. All those phrases, all the same thing. It's a BIC code. It's your identifier. It's your address on the Swift network. So the BIC has 8 characters in the code, and 11 when you include the 3-digit branch code, which I'm going to talk about in a few minutes. So BIC codes are 8 characters long. They're used to identify a specific branch or financial institution or other participant. So that code is what identifies who the message is going to get sent to. It also identifies the sender. So the sender has a BIC and the receiver has a BIC. And that's how the network knows who the sender of the message was and who the receiver of the message is. The BIC operates like an address that the Swift network uses to route message to the correct bank, financial institution, or network participant. So it could be a bank, it could be a brokerage house, it could be a network participant, like it could be DTC, or it could be an exchange, or it could be some other participant in the network. So here's how bitcodes work. I'm going to give you an example of a bitcode that's assigned to an Italian bank named Unicredit Banca. That's the name of the bank. It's in Italy. It has the headquarters in Milan, Italy. So it was assigned a SWIFT bitcode of UNCRITMM. And we're going to explain what that means. So Unicredit Banca, headquartered in Milan, has a SWIFT bitcode of UNCRITMM. So what happens is the first 4 digits of the bitcode are the name of the institution, UNCR. So UNCR, it means Unicredit Banca. So in theory, any messages to any BIC, because a single financial institution can have multiple BICs. So because a single institution participant can have multiple BICs, any message routed to UNCR, you know that that's a message for Unicredit Banca. You will see that there are cases where financial institutions have different legal entities with different names. And there are lots of examples of that, but I'm not going to bore you with that. But for this conversation, the first 4 characters identify the name of the financial institution or participant. So that's the first 4 digits. Now the next 2 characters are going to identify the country with this particular destination is routed. So in this case, it's IT for Italy. So UNCRIT is Unicredit Banca in Italy, because they might have they might have operations in Switzerland, in which case it would be UNCR and then the 2-digit character for Switzerland. Or maybe they've got a office in London with a BIC address, and that would be UNCRGB for Great Britain. Or maybe they've got an office in New York, and that would be UNCR US. The point is, the first 4 digits tell you the name of the participant's bank or institution. The next 2 digits are the country code. And the next 2 digits are a location or city code. I don't want to say this is always a city code, because you'll see some cases where, like in the US, sometimes you'll see New York is listed as 33, but you'll say, oh, I see somebody who's in Pennsylvania and they're 33, or Boston's 33. There's multiple, there can be multiple city codes or location codes, but they're basically a locale code. Now, in this case, the Milan and the Milan region in Italy has the code MM. So the BIC code UNCRITMM is an address, and messages addressed to that address, to that BIC, will get routed over the SWIFT network to Unicredit Banca in Italy at their Milan office. So when a message comes onto the network and it has that BIC, the SWIFT network will read that BIC and say, yes, this message is for Unicredit. It's going to go to Italy, and it's going to go to the Milan office of that institution. So that's how the BIC is broken down. Now, in addition, you'll also see there's 3 characters added to the end of the BIC sometimes. And it's really not part of the BIC, it's the branch code. And why I say it's not part of the BIC, because the branch code is not used by the SWIFT network to route the message. The idea of the branch code is when the message arrives at its destination, in this case, Unicredit Banca in Italy, in Milan. When the message arrives at the institution might have different operations, different teams, different groups. So they get lots of different SWIFT messages. So the 3-digit branch code is used for the institution internally to route the message to the appropriate organization within their firm. So the Bitcode is used by the SWIFT network to deliver the message to the appropriate destination, and the 3-digit branch is used at the destination to route it internally in their organization. So we're going to talk about these branch codes. The last 3 characters are optional, right? But organizations use it to assign in individual branches. Unicredit branch in Venice happens to have a branch code that they use called ZZZ. So in this case, the SWIFT network gets a message, UNCRITMM, with a branch code ZZZ. SWIFT will deliver this message to Unicredit in Italy, Milan, and then once they get the message, they'll look at the branch code ZZZ and route it to the appropriate organization, the appropriate part of their organization. So that's what the branch code is. Now again, the branch code is optional. You don't need to put a branch code on a message. If you do, it'll default to XXX or ZZZ. I think it's XXX. Now, to talk more about this, I'm going to give you some more examples. The following are some examples of Bitcodes. Again, I just picked these out of random, looked on the internet, found some ones, but Citibank is an example. Citibank has a Bitcode called, by the way, Citibank has dozens of Bitcodes. They don't have just one Bitcode. There isn't just one Bitcode for Citibank. Citibank has a number of Bitcodes. But as an example, one of the Bitcodes they use is CITGB2L, which that, I can look at that, I can tell you that that's Citi, CITI. So I know this is going to Citibank. GB, I know it's going to Great Britain. 2L, I know it's going to London. So this is a BIC that's used by Citi for messages in their business to get messages to Citi in the UK, in London. Now, Citi also has a BIC they use that's used quite a lot for CITI US 33. Now, I know from looking at this BIC, I don't have to be an expert in SWIFT to know that this is going to Citibank in the United States, 33. I know that happens to be New York or the New York region or the Northeast region of the United States, probably New York, right? So again, Citi will have multiple BICs in multiple regions, multiple different parts of their business will use different BICs. Fidelity is an example. I just used Fidelity as an example. Fidelity, as an example, is also called has a company called National Financial, right? National Financial Security Corporation. So National Financial, which is a Fidelity company, has a BIC, NFSC, so I know it, NFSC, I know that's National Financial. I know that's Fidelity's National Financial. US, I know it's in the US. 33, I know it's New York. State Street Bank, for example. SBOS, I know that's State Street Bank. That's the 4-digit code that SWIFT uses always to identify State Street Bank. US 33, I know it's in the US, I know it's in the Northeast. I think the 33 could be New York, it could be Boston. Charles Schwab is an example. CSCH. So I know that's Charles Schwab. US, I know it's the US destination, and 6 6S. I'm not so sure where that is located. I'd have to look up the 6S, but I know it's somewhere out west, probably California or Texas or someplace. I'm not sure. But those are examples of bank BIC codes that could be used and how you might read them. Now, I want to give you some examples, some branch codes and how they're used. So I said the branch code is only used internally for delivering messages at the financial institution, right? So I'm giving you some examples of some branches. So we talked about the BIC for Citibank. If I have a message that says the BIC is CITIGB2L and the branch is XXX, that means deliver this message to Citibank in the UK, in London, at their BIC. And then once Citi receives it, XXX is the default. It's not assigned. It means this is the default. So send it to the head office or let Citi figure out where this message should get routed to. But if you send a message to Merrill Lynch, this was my old BIC. I used to run the Swift at Merrill many years. MLCO US 3G. MLCO is Merrill Lynch. US 3G happens to be one of the codes for New York. And if you put the branch code of GBP, when that message arrives at Merrill Lynch will say, oh, GBP, we're going to take this message internally at Merrill and we're going to route it to our global prime broker area. So again, the branch is not used by Swift to route the message. The branch is used once Swift has delivered the message to the destination. The destination looks at the branch and uses that to route it to the appropriate place within the organization. So this message would come into Merrill Lynch, and then Merrill Lynch systems would route it to the prime broker area. This is an example of Charles Schwab. Charles Schwab has a BIC out there and some instructions. If you use this BIC, this message will get to Charles Schwab. And if you put the branch on it of WTS, once it gets to Charles Schwab knows that WTS is their wire transfer area. So the BIC will get the message to Charles Schwab. And then once it's at Charles Schwab systems will read the branch and use that to route it to the appropriate organization within Charles Schwab. Okay, now let's move on to conversation a little bit more. Swift standard reusable message backbone for domestic and cross-border flows. So as I've talked about, Swift, it has this amazing network. It's a backbone and can be used globally for really complex transaction flows, right? Where you've got investors, distributors, transfer agents, concentrators, portfolio managers, fund companies, fund accountants, fund custodian trustees, cash agents. They all can participate together on the Swift network. Now, they may not all be on the Swift network, or some of them may be on the Swift network, but they're using a third party for the network connection. But one of the powers of Swift is that where you're doing global transactions cross-border, where some of the participants might be in the US, and some could be in Asia, and some could be in Europe, and some could be in Africa, and some could be in South America, they can all participate in a smooth, standardized, secure transaction, end-to-end transaction process using the Swift network. That's one of the powers of the Swift network. Again, I mentioned quickly that Swift can be a protocol. The Swift network has their own network protocols, right? And you can use, if you use the Swift network, you have to follow their Swift protocols. And there's several of them actually. So I talked about Swift having a physical network, but they have they use a protocol called Interact. They use a protocol called FileAct. They use their own browse, right? These are different. And FileAct, I believe, is the one that delivers file level transfers. I mean, typically we always used the FIN network, which was the financial message network. But the point is that Swift has their own protocols. Originally, years ago, it was all X25, but they moved off that. That's all gone. There's no more X20. I don't believe there's any more X25. Could be, but maybe I'm not aware of anything, right? So in 2005, they replaced the X25 network. Again, let's talk about the secure. If you're on the Swift network, which I've said is highly secure, they've got two types of connections. They use SLS and they use PKI. So you can use either login select or you can use public key infrastructure. If you use SLS, you have customer A, customer B. They both have their secure ICC, and if you look here, it'll show the how the FIN network access with the security and the relation. One of the things that's interesting about Swift is if you want to communicate with another participant of Swift, you have to do what's called a bilateral key exchange. So let's say Bank A wants to send messages to Bank B. Prior to sending a message to Bank B, Bank A and Bank B have to exchange keys. They have to both do a special type of message that says, hey, I'm going to talk to you and I need your key and you need my key. So they do a bilateral two-way exchange of keys. And that if that doesn't happen, messages can't be exchanged between the two because everything is secure and encrypted. And this is one of the ways that I say that the Swift network, when you use the Swift network, it's highly secure because somebody can't hack into the Swift network and then just send you messages. Somebody can't spoof it and send you messages saying that they're another participant and that they want to get in and do your messages, because you would have to have done a secure bilateral key exchange. So they'll do that bilateral key exchange can either be SLS or PKI. But the point I'm making here is in order for two participants to communicate with each other, they have to do this key exchange. So everything that happens between them is highly secure and not visible on the network. So the Swift network doesn't see the content of your message. Everything you're doing is secure. Swift standards, right? Swift has become an industry standard for syntax in financial messages. Message formats formatted to the Swift standards can be read by, processed by many well-known financial processing systems, right? So where this was really powerful is if you're using the Swift message format, well, there's lots of software packages that know how to read a Swift message. So you can standardize your computer processing internal, right? So a good example is a company, Volante. Volante is a software company that lets you format messages and process different financial messages, right? So what happens is because you're using the Swift message format and it's an industry standard, you're speaking a language that everybody can speak, right? Other computers know how to handle Swift message formats, can be programmed to handle, can standardize. So that's one of the powers of the Swift message, right? It isn't a case of you're talking German and I'm talking Chinese, so therefore our computers can't speak to each other. If we're both doing Swift, our computer systems and our business processes should still work. Swift cooperates with international organizations by defining standard message formats and content. Swift is also a registration authority for the following ISO standards: the ISO 9362, which is a banking telecommunication message, ISO 10383, which is the 2003 securities and related financial instruments standard, ISO 13616, ISO 15022, probably the one you hear the most about, and the big one here is ISO 20022, right? So these are ISO standards, International Standard Organization standards, for how messages should be processed and as set up. So these are international standards, and SWIFT is a registration authority for those standards for ISO. I have some examples here of standards here. Not to spend too much time on standards here, but for instance, ISO 15022, basically, instruct receipt of securities free of payment. Okay, if a account owner wants to do that instruct, they use an MT540 message, and the receiver confirms that using confirm receipt of securities free of payment using an MT44, right? So as another example would be, if you want to do instruct to receipt of securities against payment, the account owner would send a MT541 to the account servicer. The account servicer would respond to the MT545. So these are all part of well-documented industry standards that are part of ISO 15022 for clearing messages, right? And these are things that brokers and global custodians are doing all the time. It's instruction for receipt of securities free of payment, confirming the transaction, or instructions to deliver securities against payment, an MT543, which the response would be a MT547, right? Those standards agreed upon mean that a brokerage firm can change banks, because as long as you know that your bank is, your custodian is using the standard, you can move from, in theory, a broker could move from Citi to Chase or any other brokerage company, any other custodian, because they know that the custodian is processing messages, processing transactions using the ISO 15022 standard, using SWIFT, so they know that their computers will be able to speak the same language, the same standards, whether they're dealing with Chase or Citi. So that's the power that we have here. Real quick, there are different types of SWIFT messages, but they're pretty easy to understand. Any of first of all the SWIFT message types, the name of the message type will start with MT for message type. And then any message that's a system message in SWIFT will be MT0 and then a 2-digit number. And all the payment numbers will be MT1 and then 2 digits. So we always talk about banking messages. You'll hear people talk about wires as MT101s, right? Financial institution transfers. So when you're doing a transfer from one bank to another, they're MT2 and then 2 digits. And all the treasury market messages are MT300 messages. And all the collection and cash letters are MT400 type messages. And all the securities market messages, which I'm very familiar with, are the MT500 series messages, and so on, until you get to the MT9, which those are the cash management and some of the free format messages are all the 199, but cash management and customer status. So again, the 100 messages and 200 messages are banks, wire transfers, money transfers, and the 500 messages are the security transactions. So that's why people find it very easy. So I brought up here some of the examples of the as I explained earlier, the MT5 whatever messages are all securities markets. So let me show you the MT500 messages. There's instructions to register, trade status, which is MT509, client advice of execution, MT513, security loan confirmation, MT516, settlement of pending transactions, MT537, receive against payment, MT541. These are all securities transactions, processing securities, use all these transaction types. These are all messages that when put together and processed with a counterparty can be used to execute securities transactions or part of security transactions. And then you'll always see in every message type, whether it's the MT100s or the MT200s or the MT300s or 4, in every case, the 98 messages are proprietary messages between the counterparties. So they are free format, proprietary, where the message block contains whatever the two counterparties have decided to use in their own proprietary message format. And the MT99s are free format text messages. And I'm going to go through a message in Swift messages are tag delimited messages, right? So a Swift message, let's get into the details of Swift messages. They're tag delimited and they're broken down into blocks. So block 1 is the header block. So when you see a Swift message, the header block will look something like this, right? It'll have this, the curly brackets to the curly brackets, right? And I know that this is an F, so I know it's a fin type message. And how the block is used for providing information, basic information on the routing of the message. And then block 2 is the application header block, right? So this is block 1 and this is block 2. So this tells me, you see where this says 101? So this tells me that a 101 message is a bank payment message. So I know from this that this message was a bank payment message. So the first block tells the network how to route the message. And now that message comes here, I know this is a bank payment message. Block 3 is the user header block, right? As an example, we said this was tag delimited. So I know that the tag 108 is the message user reference number. This is a message reference number. So this A, B, C, D, E, F, G, H, 1, 2, 3, 4, 5, 6, 7, 8, that's a reference number that the user of this message identifies this message as. So if the back office of your organization gets this message, they pick up the phone and they call the back office of the counterparty. They say, hey, I got a question about user reference number, message user reference number, A, B, C, D, E, F, G, H, that's the number they use internally to track down that message. Block 4 is the body of the message. That's the payload of the message, right? So here's an example of a block 4 message for this 103 payment. So 20, block 20, see the 20 column, that's the sender transaction reference number. So whoever sent this message, that's the reference number for the transaction. Whereas this is the reference number on the message, this is the reference number on the transaction. That's what their financial system will know this message as. This is the ordering customer, the payee. In this case, it's a company, Biodata, GJG, H. And this is who the money's being paid to, block 59. So biodata in Zurich is paying St. Jensen, and block 5 is the trailer block. So this message, you can see the bit code here of the sender and the receiver. Right? You can see that you can pull this message apart and you can figure out who the sender is from the BIC, who the receiver is the BIC, and in this case, it's a wire transfer. And it looks like it's euros. Block 32 is telling you I believe the amount of the message. So that's the SWIFT message. You go online, there's plenty of tools and sources where you can look up SWIFT messages and figure out how to read them. But the point is you read them as 5 blocks. Block 1 is the header block routed by the network. Block 2 is the application header. Block 3 is the user header. Block 4 is the actual payload of the message. And block 5 is the trailer with the trailing information. Again, I had this out here as with the MT548 settlement status processing advice message. And on the right-hand side here, you'll see this is the actual message. And what's mandatory fields? What are optional fields? What's the tags? Because again, it's a tag delimited message. So when you read the message, when we read these messages, I took the tags. You'll see there's a colon and then 20 and then a colon. That's the tag. So you know that the tag is, I'm sorry. You know that the tag 20 is always going to be the sender transaction reference number. In any SWIFT message, a tag 20 is always going to be the sender's reference number. Just like a tag 50. You see it says colon 50 colon. That's always going to be the ordering customer, the name of the ordering customer, the payee. And the 59 is an example of tag. See, it's colon 59. So when your computer reads this, it reads colon 59 colon, and now it knows that's a tag. So that identifies what the data is going to be. And then it reads until the end of the line, carriage return line feed. And then it knows, okay, that's the end of this field. So it knows that whatever it reads after this tag is this data. And that's how it reads it. Okay? And again, data can cover multiple lines. So he'll keep reading until he'll keep populating that until he reaches the next delimiter, which would go colon. So we know that in this case of 50, everything he reads until he finds the next tag, that's going to be what he's going to populate into the field that line 50 is named for. I hope that makes sense. Again, this is good. This shows on the right here, the breakdown of an MT48 message, 548 message, which is a settlement status processing device. And it shows you that, and again, these messages sometimes are tough to work with because there are optional fields or mandatory fields, and your counterparty that you're sending the message to might have fields that, although they're optional to the SWIFT standard, they might require it to be mandatory. So that was a lot of information. I hope I didn't confuse you too much on that. And if I did, sorry. And you can send me any questions. And now we'll move on to section 3 of the introduction to SWIFT.